Hello friends, welcome back to my channel. In this video, I'm going to show you how to make a light following robotic car. So just like the previous video, first I will explain the circuit diagram, then I will write the code for this project, and at the end we will be doing the hardware part. So let's just give a brief description about the components that you need to have for this project, for making this project. So first of all, you need to have a microcontroller. In my case, I'm using the Arduino Uno. You need to have a motor driver L293D and two gear motors, two tires, one breadboard, and the jumper wires. So this is a small list of components that you need to have for making this project. So for the circuit simulation part, I'm going to use my Proteus software. If you do not know how to install this or how to use this, you will find the link in the description box for the tutorial of this Proteus software. So here is the list of components that we are going to use. First, the Arduino or IR sensors, one motor driver, and the logic state to just change between high to toggle between high and the low state of the sensor in this Proteus software, and the motors. So let's start with this Arduino. So first of all, let's just place the Arduino in our workspace and place the motor driver here. You have to just short circuit enable 1 and enable 2, VCC1 and VCC2, and you have to just short circuit these two short circuit points to give a common power source for these two. You have to remember one thing, that you cannot use this Arduino as the power source, but in my case I am not having any other power source here, so I'm I am not having any other option instead of using this. So I'm using my pin number 8, 9, 10 and 11 as the output pins for this motor driver for this project. So my pin number 8 will go to my input 1, pin number 9 will go to input 2, pin number 10 will go to input 3, and pin number 11 will go to input 4. Pin number 8 and pin number 9 are the input pins for my motor 1, and pin number 10 and pin number 11 are the input pins for my motor 2. So this is the input part is over. Interfacing with this motor driver with the Arduino is over. Now short circuit this ground point, and from the terminal section place a ground point here, and just like this. Now place the two motors from the component section. Choose motors, motor 1, motor 2. This is going to be my motor 1, which is connected with output 1 and the output 2. These output 1 and output 2 are the pins for my motor 1, and this is in this way you can connect the two motors with your LDR L293D motor driver. Now before interfacing the sensor with this, let's just write the code to control these motors, or just to interface this motor driver with this Arduino. So go to Arduino IDE, and since I'm using my pin number 8, 9, 10 and 11 as the output pins for this project, so I have to declare these pins as the output pins. So first, int b1 equal to 8, b2 equal to 9, b3 equal to 10, b4 equal to 11. So in this way I have initialized these 4 pins. Now in the void setup function, I have to declare these pins as the output pins. So void setup, to declare any pin as the input or the output pin, you have to use the pin mode function. Pin mode button 1 comma output. Copy this command line 4 times. Copy this command line and paste it 4 times. 2, 3 and 4. Change the buttons, button 2, button 3 and button 4. So in this way I have declared these 4 buttons as the output pins, these 4 pins as the output pins. In the void loop section, I will be rotating my motor in the forward direction for the 2 seconds, and in the backward direction for 2 seconds. So for that, use the digital right command button 1 comma high. Now copy this command line and paste it. Copy this command line and paste it 4 times. So button 1, button 2, button 3, button. So first will be high, second will be low, button 3 will be high, and button 4 will be low. And to add a time, use the delay function. For 2 seconds, just enter 2000 here, and again copy this section of code and paste it over here, and just toggle the high and the low state of the buttons, low and high. Now just compile this code and copy the address of this code and paste it in the Proteus. Double click on the Arduino and paste this address in the Arduino program file. Click on OK and start the simulation. Here you can see that my two motors are moving in the forward direction for the 2 seconds, and then in the backward direction for the 2 seconds. Now the interfacing this motor driver with the Arduino is over. Now it's time to interface the sensor with this. Now go to obstacle detection sensor. let's just interface our two sensors here. So this is my sensor 1, and this is my sensor 2. Just short circuit the VCC and the ground pins of these two sensors to give a common ground and a VCC point for these two sensors. From the terminal section, add a power source and a ground and the power source. In this way, we have connected our two sensors with the ground and the power. So this is our infrared sensor 1, which is going to be connected on pin number 3, and this is our infrared sensor output of our infrared sensor 2. It is going to be connected to pin number 4. Toggle the state of these sensors. You have to use this logic button or logic state. You have to just toggle this from 0 to 1 and 1 to 0 to change the state of these to the output state of these sensors. So let me just explain how this thing is going to work. So this is the rough systematic for my this light following motor, light following robotic car. I'm using my black surface as the ground and this white layer as my track or the line which my car will be following. This is my motor 1, which is connected to pin number 8 and 9. This is my motor 2, which is connected to pin number 10 and 11. This is infrared sensor 1, which is connected to pin number 3, and this is infrared sensor 2, which is connected to pin number 4. If both the sensors are generating the low signal, my car must move in the forward direction. But if this sensor, for example, say infrared sensor 1 or IR sensor 2 is generating the high signal, let's choose our IR sensor 1 is generating the high signal. That means this sensor has entered in this on this white surface, and this is generating the high signal because this black body is absorbing all the radiations emitted by the infrared sensor. They strikes with this black surface and get absorbed completely. So they are not getting reflected back to our sensor. So this way, our sensor is generating the low signal on the output state on the output pin. But once this sensor reaches on this white surface, these radiations that are emitted by the sensor reflects back to the sensor, and as they are detected by the sensor, so sensor will generate the high state on the output pin. So if the sensor is generating the high state on is generating the high signal on the output pin, that means the sensor has entered on this white surface. So we have to move this sensor back from white to the black surface. So for this, we have to just stop this motor and keep this motor continue rotating. So if this motor is rotating and this is not rotating, this motor will push our car in this direction. So this sensor will move back from white surface to this black surface and generate the low signal. In the same way, if this sensor come on this white surface, so this motor must stop and this will continue to rotate to push our car in this direction. So if both the sensors are generating the high signal, so both the motors must stop. So this is the logic behind this ultrasonic this infrared sensors, how this tracking of line works. If you are using the white surface as the ground and this black layer as your track or the line which your car must be following, so you have to just use the if sensor state is equal to low. Okay, so let's just write this section of code in the Arduino IDE. So just delete this section of code and declare the two variables. First you have to declare the pins here. So IR1 equal to 3 and IR2 equal to 4. Okay, so int value 1 equal if value 1 is equal int value 1 is equal to dig digital read IR1, value 2 equal to digit digital read IR2. So these two values store the state of output pin of our infrared sensor. So we have to use the logic state on these two values. So if value 1 equal to high, that means if value 1 equal to high, that means this sensor has entered on this white surface. So we have to push the sensors back on the black surface. So we have to stop the motor 1 and continue rotating the motor 2. Okay, so for this, what we have to do, we have to just write dig digital write v1 comma low. We have to stop the motor 1 which is connected to pin number 8 and 9. So we have to use the same state for both the pins. So in this way, if you are using the low for the pin number 8 pin number 8 and pin number 9, this motor will stop rotating, and we have to just keep rotating our motor 3 in the forward direction. So this must be high, and our pin number 4 must be low. So this must be low. If our second motor is rotating, if this motor is rotating, this will push our car in this direction. So this sensor will come out from white surface to black surface. So just again copy this section of code and use the else command here. Else if value 2 equal to high, that means if this sensor, now if this sensor is on this white surface, so we have to stop this motor and we have to keep rotating this motor one. For this we have to just continue rotating this motor and we have to stop the second motor. Now else if value 1 equal to high, if value 1 equal to high and value 2 equal to high, that means if both the sensors are generating the high signal, we have to stop the motors. So for this, in this way our whole section of code is complete. Now just compile this code to check for the errors. Here we got an error. So the error is we forget to add the 1 and 2 with the sensor name. So IR1 and IR2. Now just compile this code again to check for the errors. So we are free from error. Now if you have already added this address of this code in the Proteus, so you can add it, you can update this code again and again, and you have to just compile this code and your Proteus will already fetch the updated code. So just compile this, start the simulation. Unfortunately our sensor modules are not working here, so I don't know the errors because this is the only sensor that I'm having in my Proteus. So just delete this part. You have to add this part in the circuit diagram when you are creating the real hardware, but for the circuit simulation this is not like compatible or not working here. So I'm just using this logic states to explain or just show my circuit in working condition. So for example, say this is my infrared sensor 1 and this is going to be pin number 3. This is my sensor 2 and this is going to be on pin number 4. Delete these two grounds and now start the simulation. We have to add another section of code here, or to rotate the motor. Now what is happening here, if this condition is fulfilled, motor will rotate in this direction. If we have written the code for all the conditions, but we forget to add the section of code which will rotate our motor in the forward direction. So in the else just copy these 4 lines and paste here high. Now again compile the code and go to Proteus and start the simulation. So you will see here that motors are rotating in one direction. So for example, for example say my this sensor has entered on this white track. So I have to just toggle the output state, or toggle this state from 0 to 1. So with this, my motor 1, which is connected to output 1, this motor will stop rotating, and my motor 2, this is my motor 1 and this is my motor 2. If this sensor goes high, generating the high signal, my motor 1 must stop and motor 2 must continue to rotate. This is my sensor 1. If this is generating the high signal, so this motor must stop and this motor must continue to rotate so that this sensor comes out from white track. Okay, so let's just toggle this state. Here you can see that motor 1 has stopped here and motor 2 is rotating. Push our motor from white track back into the black track. So just again toggle this state and let's test for our sensor 2. And with this, our second motor has stopped. Now if we have toggled the state of our second sensor, which is pin IR sensor 2 connected to pin number 4. That means this sensor is now on white track and we have to move this sensor back into the black track. For this, we have to stop motor 2 and keep rotating motor 1. And with this, motor 2 is has stopped rotating and motor 1 is continue working. Part is over. Now let's upload the code. Let's just first compile this code to check for the errors, and after that we will upload this code in our Arduino microcontroller. So it shows that done uploading. So let's upload the code that we have just written here. You can see that my two motors are rotating in the reverse direction. One is rotating in the clockwise direction, another is rotating in the anti-clockwise direction. So we have to edit the code. Change button 1 to pin number 9 and button 2 to pin number 8 and upload the code again. Sorry, I have not plugged in the USB cable.